Ideas are so fundamental to how we think, we kind of forget they even had to be invented. The rules of logic, the whole process of proving something is true, these didn't just appear out of nowhere. They had a beginning. And today we're going to trace that beginning back to what might be the world's most influential textbook, a book that gave us so much more than just shapes. So let's explore this blueprint of logic.
Okay, that might seem like a bit of a riddle, right? But the answer really gets to the very heart of why we have geometry in the first place. The connection is a really practical problem that demanded an ingenious solution, a solution that, believe it or not, would eventually change the entire world.
So the story of geometry doesn't start in some pristine classroom with a compass and a protractor. No, it starts in the mud. It starts with the very real problems of survival, farming, and just building stuff. I mean, the word itself comes from the Greek, geo for earth, and metrain for to measure. Literally, earth measuring. That's where it all began. I want you to imagine you're a farmer in ancient Egypt. Every single year, the Nile River floods. Now, that's great for your crops, but it is terrible for your property lines. It just washes them all away. So to figure out who owned what, the Egyptians had to become absolute masters of practical geometry. They developed all these rules and techniques to measure areas and redraw the boundaries. And this exact same practical knowledge allowed them to build the pyramids with just stunning accuracy and even figure out the volume of their granaries. And it wasn't just Egypt. Way over in the Indus Valley, around 3000 BCE, people were building these incredibly well-planned cities. I mean, when you look at the ruins of Harappa and Mohenjo-daro, you see a society that was just so skilled in measurement. Roads were laid out parallel to each other, houses had different kinds of rooms, and they even had advanced underground drainage. But what's truly remarkable is the precision in their building materials. Their bricks were standardized to a precise 4:1 ratio. That's applied geometry on a massive scale. So, here's the crucial point in all this. All of these incredible achievements were based on a kind of how-to manual. They had recipes that worked. If you do this, you get that result. But their knowledge was totally unsystematic. It was just a list of results passed down from one generation to the next, without anyone asking that one single most important question. Why does it work? And that question, that simple shift from how to why, is where our story takes a really dramatic turn. This is the Greek Revolution in thought, where the focus changed from simply using a tool to understanding the principles behind it. And you can really see the difference right here. On one side, you've got the Egyptians and Babylonians, totally focused on practical results, a very what works kind of approach. But on the other side, you have the Greeks, with this new emphasis on reasoning, on the search for logical proof, and on building a whole system of knowledge through deductive reasoning. See, they weren't satisfied just knowing that a method worked. They had to prove why it was guaranteed to work every single time. Now, this new way of thinking was championed by pioneers like Thales, who actually gave us the first known geometric proof, and of course, his famous pupil, Pythagoras. These were the guys who started laying the groundwork for a complete revolution in human thought. This new way of thinking kind of simmered for centuries. And then, around 300 BCE, one man took on the absolutely monumental task of collecting all of this known work and arranging it into the most famous math book of all time. And this, of course, brings us to our main character, Euclid. We really don't know a lot about Euclid the man, but we do know he was a mathematics teacher in Alexandria, Egypt, which at the time was pretty much the intellectual center of the entire world. He wasn't necessarily the greatest inventor of new geometry, but he was something way more important. He was its greatest organizer. What Euclid did was just incredible. He took centuries of geometric knowledge, from the Egyptians, the Babylonians, and especially all the work from the Greeks, and he organized it all into a single, coherent, logical system. This masterpiece was called Elements, and he divided it into 13 chapters, each one called a book. So how'd he do it? I mean, how do you even begin to build an entire system of knowledge from scratch? Well, think of it like constructing a building. You can't start with the roof, right? You have to start with a solid foundation. The Euclid system has this clear 3-level hierarchy. First, you've got the ground itself, what he called undefined terms. Then you lay the foundation, axioms and postulates, and only then can you start building the structure, piece by logical piece, with what he called theorems. Okay, let's break that down. First up, the ground. Euclid realized that if you try to define every single word, you get stuck in an endless loop. I mean, his definition of a point was that which has no part. Okay, but then you have to define part. See the problem? So his idea was genius. He decided that some concepts like point, line, and plane were so basic that we should just leave them undefined. We just intuitively know what they are. This breaks the chain and gives us a place to start.
All right, next, the foundation. Euclid laid down some basic assumptions that were considered obvious universal truths. He called these axioms. Things like, the whole is greater than the part. I mean, yeah, of course it is. These are statements so obviously true that nobody would argue with them, and they apply to all of mathematics, not just geometry.
Then, he added another layer to his foundation, which he called postulates. Think of these as the specific rules for the game of geometry. Again, they're assumptions we accept without proof, like the fact that you can draw a straight line between any 2 points. Okay, so with the ground set and the foundation laid, Euclid was finally ready to build.
And what he built, it changed everything. This system wasn't just about triangles and circles anymore. This was a new way of thinking, a new way of establishing what is true. So just how powerful was this foundation? Well, from just a handful of undefined terms, axioms, and postulates, Euclid used pure deductive reasoning to prove this many propositions, or theorems, 465. Each one built logically on the ones that came before it, creating this unbreakable structure of knowledge. For over 2,000 years, The Elements was the textbook for geometry. Its impact was just immense, influencing, as it says here, the whole world's understanding of geometry for generations to come.
And this brings us to the most important takeaway of all. Euclid's greatest gift wasn't a book about shapes. It was the method, the idea that you can start with a few simple, accepted truths, and from them, use pure logic to build complex, certain arguments. This became the blueprint not just for mathematics, but for science, for philosophy, really for all of modern rational thought.
So think about it. We started by solving the practical problem of a flooded field, and we ended up with the blueprint for building certainty itself. The Elements gave us a tool to prove truths about abstract shapes. The question it leaves us with is this: what other, more complex truths about our own world can we build using that very same blueprint of logic?